So to start this problem off, we want to make this easier. So 2x plus y, we're going to change that. So instead of 2x, what we're going to think of is just replacing what we had before. So keep that first one as a. So a is going to replace 2x. And the second part here, the y, we're going to replace that with b. So we're going to say b equals y. And the purpose behind that is just so we can be consistent with what we already know about how to work everything out. So when we replace it, this expression is going to look like, let me go ahead and keep the colors the same. This expression is going to look like a plus b to the fifth power. And when we work this out, we're going to notice that the number of terms that we end up with, if you notice the pattern on the last one, is going to be one more than the power. So if the power is 2, there are going to be 3 terms. If the power is 4, there's going to be 5 terms. If the power is 5, there are going to be 6 terms. So notice that we have 6 blank spaces here because the power is 5. So one more than the power. The a is going to start off at its largest power. So it's going to start off as a to the 5th. And b is going to end up at b to the 5th power, but we'll worry about that in a second. Let's concentrate on a for now. So we know that a is going to decrease by 1 power each time. So a to the 5th is going to become a to the 4th for the next term. Decrease that power by 1, and on the next one is going to end up being a to the 3rd power. We decrease it by 1 again, and it'll be a to the 2nd power. Decrease the power by 1 again, and it'll be a to the 1st power. The last one is going to end up being a to the 0 power, which again, remember, a to the 0 power is 1, and we don't really need to write that for our purposes. So now let's think about what's going to happen with b. So again, b starts off as the lowest power, so b to the 0. And then b is going to go up a power each time. So add 1, that's b to the 0. Add 1, that's b to the 2nd. Add another 1 to the power, that's going to end up being b to the 3rd. Add another 1 to the power, and that's b to the 4th. Add another 1 to the power, and that's b to the 5th power. As a quick check to make sure we did this right, 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and then the last one here is 5. So all the powers are 5, just like how they should be according to our example. We know that b to the 0, for our purposes, we don't need to write it. So let's just rewrite this here. And what we're going to need to do now is to figure out the coefficients. So we need Pascal's triangle to get the coefficients. So the 0th row is the first one that starts with 1. Power of 1 would be the next row. That's a 1 and a 1. The next row is going to be, we're going to start with a 1 and a 1. So we're going to start with a 1, end with a 1. We add those middle values, we get 2, and we have 1, 2, 1. So those will be the coefficients if we do the 3rd power. The 4th power, again, is starting with a 1. We're going to add again, so that's 3 this time. And then we're going to end with a 1 also. So that's what happens for the 4th power. For the 5th power, which is what we're trying here, all of them start with 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then we're going to end the same way we did in the beginning with a 1. So this basically tells us the powers that we're going to need to, the coefficients that we need to put in. These are the coefficients here. So we have 1, 4, 6, 4, and 1. Oh, hold on a second. I miscounted. Sorry. So let's fix this. All right, so let's just erase this. And it should have been 0, 1. I promise you, I can count. 2. This row here is 3. Next row is 4. So what we need is the 5th row now. So for the 5th row, which represents the power of 5, we're going to start with a 1, just like we did before. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is also 10. 4 plus 1 is 5. And then we end with a 1 also. So all of these numbers here represent the coefficients that we need. So let's fill them in. So first number is 1. Next number is 5. Next number is 10. The next number is 10 also. Then we're going to have a 5 for the next coefficient. And then the final coefficient is going to be 1. So we need to apply all of this now to get the actual answer for what we're looking for. And I want to say, this process seems like it's pretty long, but trust me, it's a lot longer to do 2x plus y times 2x plus y times 2x plus y, basically multiplying 2x plus y times itself 5 times. But anyway, we have a to the 5th is the same as 2x to the 5th. And if we did 2 to the 5th power, we would end up with 32. And if we do x to the 5th power, that's just x to the 5th. So that's what we're going to have in place of that a to the 5th in our answer. A to the 4th is going to be 2x to the 4th power, since a is the same as 2x. 2 to the 4th power is 16, and then we have that x to the 4th. A to the 3rd is basically 2x to the 3rd power. 2 to the 3rd is 8, and then that x to the 3rd is still x to the 3rd. So now a to the 2nd, same process, we're just going to do 2x to the 2nd power, and 2 to the 2nd is 4, and then we have x squared. Finally, again, we know that a to the 1st was just the same as a, and we know that a is 2x. So we're going to substitute all of those back into our expression so that we can work everything out. So now this a to the 5th is 32x to the 5th, so we're going to go ahead and replace that. So 32x to the 5th and the a to the 4th is 16x to the 4th. So we're going to go ahead and replace that. So times 16x to the 4th. And let's keep the colors the same. So times 16x to the 4th. B to the 1st was just b, and we know that that's y, so we're just going to put y. Alright, so now let's do the 3rd term, and we had a 10 for the coefficient on that 3rd term. And we're going to put here the value of a squared, which is 4x squared, and y to the 3rd because we have b cubed. So now let's do the next one. We know the coefficient here is 5, so we'll put 5. And a to the 1st is really just 2x, so it's going to be 5 times 2x. and then y here to the fourth because we have b to the fourth. So on the last one here, b to the fifth is basically just the same as y to the fifth, because remember, we're just switching out b and y because they're equal. So now let's write our final answer. Let's clear all this out right now. Okay, so we need to multiply. So 1 times 32 is 32. So we're going to have 32x to the fifth. 5 times 16 is 80. So we're going to have 80x to the fourth y plus, and then 10 times 4 is 40. So we have 40x squared y cubed. 5 times 2 is 10. So plus 10x y to the fourth, and we just have the y to the fifth left over here. Let's do a quick check now. That power is 5, these powers add up to 5, these powers add to 5, these powers add to 5, and that one is 5, which is exactly what we have here. So we also know that there should be 6 terms, but it looks like, wait a minute, we have 5. So let's fix this. The problem is that we forgot to add in this term. So if we fix it, that term would have ended up here in our problem. So we need to add in an extra term. So we're going to add in 10 times a cubed, but we know a is 2x, so it's really times 2x to the third power, and then we have our b squared, but we know b is y, so we're going to say y squared and so this is what we're going to end up having to add into our problem here. We would need to put it here, and we'd end up with 80 because 80x cubed, because basically 10 times 2x to the third is going to end up being 80x cubed, and we're going to need to bring down that y squared that we had in the problem. So now if we write everything out, 32x to the fifth plus 80x to the fourth y plus 80x cubed y squared plus 40x squared y cubed plus 10x y to the fourth plus y to the fifth.